And we said on Tuesday that the corresponding angles postulate was the driving force. We said that if two lines are intersected, if two parallel lines are intersected by a transversal, then we knew that corresponding angles were congruent. We said that on Tuesday. That was that was something from the notes that we put in. That was our kind of our building block. Today we're actually going to show that the converse of this, I'm going to tell you that the converse of this is also true, is also going to be a postulate we'll build off of. So what is the converse of this statement? What is the converse of that statement?
Corresponding angles are, if corresponding angles are congruent, then two parallel lines are intersected by a transversal.
Absolutely. If corresponding angles are congruent, then what do we know? If corresponding angles are congruent, then what we can claim is that the two lines intersected by a transversal are parallel. From that statement, we can actually conclude that these three are now also congruent. Excuse me, these three are also true. And we'll actually are going to prove that this one is true together. And then if you want to, if you're curious or just want to practice proofs, you could show that these two are parallels, are true as well on your own. The alternate interior converse, well, it's similar to that, says that if alternate interior angles are congruent, I'm going to abbreviate real hard here, so alternate interior angles are congruent, then we know we have parallel lines. Similarly, the alternate exterior converse. If alternate exterior angles congruent, then parallel lines. Double lines, double parallel lines being this shorthand for parallel. If alternate exterior angles are congruent, then you have parallel lines. What should the consecutive interior converse say?
Consecutive interior angles are supplementary and they're parallel.
Supplementary? Then parallel lines. We're going to prove the alternate interior angles converse together. Nope. We're going to prove the first one. We're going to show that this is true first. And then again, as I said, on your own, you can say, for practice, you could show that those two are true. And it would be a very similar line of thought. Okay. Yes, we're going to explain why something works. We're going to prove it. So to do that, we'll start with this. We'll start with a little diagram with two lines that are intersected by a transversal. We'll start with two lines intersected by a transversal, and I've even labeled a few, and I've put a few labels in. I've labeled the top line M, the bottom line N, and I've put in a couple label a few of the angles, angles 1, 2, and 3. Okay? And we're going to show that if you start with alternate interior angles congruent, then that forces the lines to be parallel. Then they must be parallel. Okay? We're going to explain that. Well, why is that true? We know that those two things are congruent. That's what I'm going to tell you. We're going to start with that being true. If that's true, then what can we deduce? And as I kind of mentioned earlier, the whole goal is to be able to get to this spot. We want to be able to get to this relationship of the corresponding angles postulate. If we can get corresponding angles congruent, then we know the lines must be parallel. That's where kind of our jumping off point. So if I give you this diagram, what we really need to show, what you really need to get to, we really need to show a pair of corresponding angles. Are congruent. If you can get that, then we can use that corresponding angles converse to show that the lines, to say specifically the lines must be parallel. Well, can we get a pair of corresponding angles congruent in this? Is there a way we can do that? I bet you there is. Hey, Joel, what's something you might want to try?
Well, you know that 1 and 2 are vertical angles?
Okay, so we know that are vertical angles.
And then,
So
1
then
and 2 equals 3, so already we do that.
You need to start. I'm telling you that angle 2 is congruent to angle 3.
So we use the transitive property.
So then transitivity, transitive or substitution.
Shows that.
Transitive says that angle 1 is angle 3. And if you have this, then you could use the corresponding converse. To show that the lines are parallel, is our plan of attack.
So you can't just say that they're alternate interior.
That's a good thing. No, we can't use the alternate interior angles converse because we're trying to show that it's true. So you can't go and nature walk this. You can't say that it's true because it's true. Yeah, you can't do that. You can't. Not allowed to do that. Yeah, I just use that as a verb. Okay. So we're going to actually write a formal explanation. So we're going to take all this stuff that we just brainstormed and actually just put it into a nice format. We'll just clean it up. So we'll start. Let's start with what's given. Let's start with angle 2. Angle 2 is congruent to angle 3. Why? Because I told you it is. It's given. In our little brainstorm, what did we say we wanted to say is next? What was another next thing we could conclude? We say angle 1 and 2 are vertical. So angle 2 are vertical. We could say they're vertical. Well, from the diagram, they're vertical. They're drawn across from each other. That's what vertical angles are. That's a definition. That's just what vertical angles are. From the diagram, that's what we call them vertical because that's their definition. That's what they are. 1 and 2 are opposite, formed by opposite rays. 2 pairs of opposite rays. That's what they are. So if you know they're vertical, what does that tell you about their measures? They're congruent, and we said that, well, that's because vertical angles are congruent. If you want to get fancy, you can call it the vertical angles theorem, but this is what the vertical angles theorem says, that vertical angles are congruent. From our little discussion over here from the brainstorm, we said if we knew 1 was congruent to 2, we're told 2 is congruent to 3, then you could claim that 1 is congruent to 3. You can now claim that, and you could use substitution. It's the transitive property. This is definitely a transitive idea as well. I like transitive in this case. These are congruent because of the transitive property. If 1 is congruent to 2, 2 is congruent to 3, then 1 better be congruent to 3. And that's what we wanted to get to. Because if we have 1 is congruent to 3, now we can do the new thing, the new reason we said, which was the corresponding angles converse. Since we have 1 and 3, and 1 and 3 are corresponding angles, what do you know about lines M and N now? Now they must be parallel. I'll use the symbol for parallel. M is parallel to N. And why is that? Well, since corresponding angle is congruent, then the lines are parallel. And you could call that, if you want to memorize you can memorize by its name, the corresponding angles converse. You could just say, this is what I like to do, I just say if corresponding angles congruent, then parallel lines. Since you didn't know what it means anyways, if you just give me a quick explanation of what this theorem says, that would be fine too. Or you could just call it by its name, the corresponding angles converse. So on the flip side, the question says, is it possible to prove AB is parallel to CD with the given piece of information? And if you say yes, then why? So what I'm saying is, if I tell you that 1 is congruent to 5, is that enough information to say that AB is parallel to CD? Yeah. And why? What would that be? I don't know. Why?
Corresponding angles.
Converse, or if corresponding congruent, then parallel lines. Is so B, no, not good enough. C, 4 plus 6 is 180. 4 plus 6 is 180. Is that good enough?
Yeah.
Yeah, that would be what? That's the consecutive.
Angle.
Consecutive interiors converse. Or if you start with supplementary consecutive interior angles, then parallel lines. 2 and 7.
Yes.
2 and 7.
Yes.
Yeah. Alternate exterior converse. Yeah, that would be good enough. Find the value that makes these parallel.
98.
If these are parallel, if A and B are parallel, then what should be true about these two angle measures?
X minus 7 is equal to
If they're parallel, then these better be the same. So what you need to do is find the value of x that makes these two angles congruent.
What's that number?
Which means 5x
98.
minus 7 better be equal to
98.
98. When x is 21, those angles are congruent. That's the only value. Last one I just want to jot down, transitive property parallel lines. Last thing, if M parallel to N and N parallel to P, what do you know, what's a new statement you can come up with about parallel lines?
M is parallel to
Then line M is parallel to line P. Parallel lines are transitive. If you have two lines parallel to the same, then they're parallel themselves.